Sairam children, we were discussing lesson number 13, air and water. Children, in this lesson we have discussed about atmosphere, about various layers of atmosphere. We have also discussed in detail about water. Yes, about various processes used to separate the impurities from water. We have also discussed about air. Children, today we are going to discuss about properties of air. Now, in the textbook we have so many experiments to show the properties of air. The properties of air are: air occupies space, air has weight, air exerts pressure, air is needed for burning. In the end of this session, I'll be showing experiments to prove these properties. Now children, we have one experiment here discussing the property that air exerts pressure from all sides. To do this experiment or to perform this experiment, what we have to do? Take a bottle with a tight fitting cap, pour some hot water into the bottle and screw the cap tightly. Now, what is there inside the water? Along with the hot water, the air also contains water vapor, because when water is hot, it changes into water vapor. Keep the bottle in a bowl and pour cold water and ice on it. Now watch it collapse from all sides. Water vapor from the hot water in the bottle drives almost all the air out from the bottle. Most of the air from the bottle is driven out. When the bottle is cooled, when we pour cold water, what will happen? Yes, the water vapor inside the bottle will condense and there is no air in the bottle now. So the pressure exerted by it is very small. The pressure exerted by the bottle, by the air on the surface of the bottle from inside is very small now, and the pressure exerted on all sides of bottle by the air outside is much more. This makes the bottle go out of shape. So this experiment shows that air exerts pressure from all the directions. Here are the pictures in which you can see how the experiment has to be performed. Now, with the help of a funnel, the boy is pouring hot water inside the bottle and screw the cap tightly. Next, the bottle is kept in the bowl and cold water and ice is poured on the bottle. Now the bottle has gone out of shape, and the reason is, yes, because air exerts pressure from all the directions. So children, this simple experiment shows that air exerts pressure from all the directions. Now, using air pressure. Now we know that air has pressure, air exerts pressure. We have so many things which we examine in our day-to-day life, how air pressure works. Now, children, you must have observed that when you drink or when you have cold drink or any other juice with the help of a straw, then that works on the principle of air pressure. Yes, when you suck in the air in the straw, the air pressure inside the straw decreases and the pressure on the surface of the drink is more. What happens then? The air pressure inside the straw, as it is less, this forces the drink into the straw and in your mouth. In this way, air pressure works. There are few more examples. This is the example. This is how the air pressure works, how we suck or how we can have drinks or juice with the help of a straw, and that works on the principle of air pressure. Also the syringe which is used by the doctor, it works on air pressure. A medicine dropper, yes, what do? When we press that medicine dropper, there also the air pressure works, and a doctor's syringe suck up liquid in the same way. When you pump air into the tire of your bicycle, it gets harder due to increase in air pressure, which allows you to ride a bicycle comfortably. You must have observed if by chance the air from your tires goes out or your tire punctures, then are you able to ride the bicycle or any vehicle properly? No. A proper pressure of air is required to help you ride the vehicle or bicycle properly. So in this way, we have discussed today how air pressure works. Now, I am going to show the experiments based on other properties of air. Children, we are going to try this simple experiment to prove that air has weight. Now, I am going to explain what I have done. Tie a piece of string to the middle of a scale. Take two inflated balloons of the same size. Tie a balloon to each end of the scale. Make sure both the ends of the scale are at the same level. Now prick one balloon carefully so that all the air escaped from the balloon. As you can see, the end of the scale with the balloon filled with air has come down. The reason is it contains air and is therefore heavier. This proves that air has weight. Today we are going to perform an experiment. Fix two candles on a table. Now light them. Cover one of the candle with a glass. Observe. What happened? Why does the flame go out after a few seconds? Why does the uncovered candle keep burning? This activity shows that air is needed for burning. Air is everywhere, but you cannot see it. You feel it when the wind blows or when the fan is on. An empty cup or a glass is not really empty. It is filled with air. Air occupies space. Now there is an easy way to show that air occupies space. Take an empty glass and pour water into it. Water easily fills the glass. What happens to the air that was in the glass? It escaped from the top as water fills the glass. Now let us see what happens if we do not allow the air to escape from the glass. For that, we need few things like take a bowl half filled with water. Stuff the bottom of an empty glass with cotton wool. Hold the glass upside down and push it slowly into the water without tilting. Air now has no way to come out of the glass. Carefully take the glass out of water without tilting. Feel the cotton at the bottom. Is it dry or wet? What does this show? The cotton is still dry. Water could not enter the glass as air could not escape. Now push the glass into the water. Slowly tilt the glass. You will see bubbles of air escaping. Water can now enter the glass. Feel the cotton. after taking the glass out of water. Is it wet now? Yes, the cotton is wet. So, this experiment shows that air occupies space. Fill a glass with water up to the brim. Carefully place a piece of stiff card over the mouth of the glass. Make sure that no air is trapped between the water and the card. Hold the card in place with your hand. Now turn the glass upside down. Remove your hand. You will find that the card will stay in place and the water will not fall out. This is because air exerts pressure on the card from below to keep the card in place. Here, the pressure exerted by air upwards is more than the pressure exerted by water downwards. If there had been air trapped inside the glass, the card would have fallen off because of the downward pressure exerted by the trapped air.